Alrighty people, we are up to chapter 13, which is our final chapter for geometry and measurement and our final chapter for the year. And then that's it. No more stuff to learn. So this gets into spherical geometry. We're going to get right into basically leading up to working out distances on the Earth. Like between 2 points on the Earth, we're just going to assume that Earth is a perfect sphere, even though it's not. It's a little bit squashed. It's not flat, people. And, we're going to be able to use our trigonometry and geometry kind of knowledge to calculate those distances. But first we're going to start with some simple circle geometry stuff. Now, we all know, hopefully, that the circumference of a circle is 2 times pi times the radius. Yes, we've already done that. We did that in very, very early chapter 11, 2 pi r. Or remember, you can also do pi times diameter, just in case you need it. So the radius is half of this, like from the point to the edge of the circle. The diameter is all the way across. If I could draw a line straight and in the center, that would have been better, but you know what I mean. All right. So that's the easy stuff. Then, something that might not be as familiar is the arc length. So the arc length of a circle, it's instead of looking at the full circumference, so instead of doing the full circumference, the arc length is just part of the circumference. So if we look at this, can you see that there's a red outer line here, just sectioning part of the circumference here? So this is an arc, and we can find the length of that arc using this formula over here. Now this angle at the top here is the angle that's made by the arc, and then r is the radius of the circle itself. So you do the angle divided by 360 times 2 pi r. You can kind of see where this comes from. 2 pi r is the circumference, and this is like the fraction of that circumference. Okay, so the angle divided by 360 is like how much part of the circle are we trying to find, are we trying to look at? So it's pretty easy formula to use, but it can get confusing when we deal with, there's another formula we're going to deal with later on. So we'll have a look at that in a minute. So calculate the arc lengths for each of the following shapes using, correct to 2 decimal places. Now over here, I'm going to actually bring up a really important point. Remember the angle. The angle is the angle of the arc. Be careful not to just use the angle that's given to you straight away. So in this circle here, we know this empty bit is 90 degrees. But we don't want the empty bit, we want the blue part, which has this red outer line, which is the length we're trying to find. So we need to use this angle here. And we can find that angle there, because a full angle, full circle is 360, take away the 90, and we have 270. And then we're going to use that angle in our formula. So I can't be bothered writing arc length, so I'm just going to say AL is the angle over 360 times 2 pi r. Now r here is 2.4. So work out what r is and work out what the angle is first before you use this formula, because otherwise you might use the wrong one. 2.4, and then you chuck that in the calculator, and we get, so make sure if you're doing this at the same time, which I highly suggest, just make sure you get the same answer as me. 2 decimal places we want, so there we go, and it's measured, it's a length. So we need to use the units that are given to us, which are centimeters, and it's just a plain old length, so there's no squared or cubed or anything like that. Now looking at this sort of part of a circle here, so we're looking at the length around this bit. Again, Be careful not to accidentally use the empty space because that's the one that they give you. You've got to work out what this angle is. Sometimes they give you the angle, sometimes they give you the angle of the other part. In this case, they keep giving us the angle of the empty space. So remember, again, let's find the angle. Take away the 45 from 360. That gives us 315 degrees. And then chuck that. Oh yeah, the radius is 7.2. Chuck that into the formula. Now this should be eventually, after lots of practice, you should remember this formula pretty well and not have to look it up. But you can always look in your band reference. It's just that in the exam you won't have that much time. Alright, so 7.2. Okay, and then we chuck that in the calculator. We round it to 2 decimal places, and it's also in centimeters. Pretty easy. It's weird jumping from crazy trigonometry kind of questions, application questions, and then we're back to just simple geometry. It does get harder. All right, now in this same exercise, we don't just do arc lengths and circumferences, we also do areas of things called sectors and segments and stuff. So firstly, just the plain old area of a circle is pi r squared. So remember, pi times radius squared. Please don't get, even though they're easy, these formulas, don't get it confused with the circumference. Be careful. All right, now sector, and this is the tricky part, is just remembering all these different names and what they mean. A sector is like you've got a circle cake and you've sliced a piece of that cake. Can be any size, okay? But that slice is the sector, or a pizza, if you want to think of it that way. So you've got, again, you've got the angle section of that sector, and you've got the radius, and you want to figure out, so it's not just figuring out the length here, which is the arc length, it's figuring out the whole area of this space here, okay? So think of it again as like a fraction of the area of a circle. So there's that fraction bit again, the angle over 360, times the area of a circle. So that's one way of remembering it in case, you know, you have a little mental blank and you don't have time to look up your band reference. And then you've got segments. Now segments are when you don't know how to slice up a cake and you just slice it straight across the circle, which, you know, is just so totally wrong. So you've got, if you slice it up like this, just into 2 parts, you'll have a smaller version and a bigger version. The minor segment is the smaller part, the major segment is the larger part. We've got the area of the minor segment bit, okay? So the area of the minor segment is the area of the sector minus the area of a triangle. So if you can see, and again, it's not the end of the world if this makes not much sense, as long as you remember the formula or can find the formula to use. But the reason why it's the area of a sector minus the area of a triangle, so if you imagine this whole slice of cake highlighted, that would be the sector. And then this empty, like this red part here is the triangle. And then the blue part is the segment. Okay, so if you did the whole slice, take away the triangle, you'd be left with just the blue bit, which is the bit that we want. So it's like using those 2 formulas that we've already had before, or sorry, the one formula from sector, and then minus a special kind of way of calculating the triangle. It's like method 2 when we did areas of triangles, only that you're using the radius instead of like A and B. And then this is just I guess a simplified version of it. So these are, just so you know, because some people get confused with this formula, these are the same formulas. It's your choice which one you want to use. Do you want to use this one with the brackets? Do you want to use this one without the brackets? It will all work out in the end. It's whatever works best for you. All right, example 12. So from the circle shown, which has a radius of 8 centimeters, calculate the area of the blue sector. And then I think we're gonna do a segment after that. So let's do the sector, which is the whole blue slice, the slice of cake. Sectors are slices of cake. So let me just look it up. There we go. So just remember to use the correct formula. Let's go back to area of sector. It's that one there. Let's write it out. A sector is that fraction of, so the angle over 360 times pi r squared. So what have we got here? Now in this case, they've given us this angle inside the blue bit. So we're going to use that 95 and the radius is 8. And then you chuck that in the calculator, we get 53.0580, which is rounded. It doesn't tell us to round, but it's supposed to be 2 decimal places. Just remember, if you don't round correctly, you will not get any marks in the exam. Now this is area, so we have to do the squared on the units. So we're chopping back and forth with length and area and so on, so just be wary of what you're calculating. So that is the area of this blue part, the sector. Now we're going to find the area of the minor segment of the circle. So let's go back to our circle. Basically that's this bit here. It's not going to listen to me, is it? No. That part. Okay. So remember, you sliced it the wrong way across, slice the cake up the wrong way, and so it's the area of this bit. As long as you're using the correct angle and the correct radius, then, and the correct formula, you won't go wrong. So recognizing that this is a segment, that's the formula there. Let's actually keep this open so I can flip back and forth to my circle. So let's write out the formula. I'm going to do the one with the brackets. So area of minor segment is r squared, and then brackets 360 degrees times pi minus half sine of the angle. There's a lot going on in this formula. So just remember, when you've got something next to something else and there's no like operation between them, it just means that they're multiplying each other. So the radius, go back to the circle, is 8 and the angle is 95. That's all we need to know. So radius is 8 squared. Don't forget that squared, they're easily forgotten as well. 95 over 360 times pi minus half sine, and then this is 95. And then you be careful when you put this in the calculator. Try this as well, just to make sure you know how to put this in, so you can make sure that you get the same answer as me. And this is also area, so it's centimeters squared. So that's it. We've learnt about arc lengths, areas of sectors, and areas of segments. So make these nice and clear in your band reference. Draw diagrams to show which is which, so you remind yourself what's what. And that's it. Have fun.